All right, you guys, let's look at the second part of chapter 17. And I apologize. I looked at all the examples. There were 9 examples, and I thought, well, I'll do 5 one day, 4 the other. Well, at the end, I'm not going to do the last 3 examples because they don't pertain to the stuff that we're assigning. So I have one more example to do for you here. So if you turn to page 482, we'll look at the maximum area problem. Okay, so it says, a farmer with 100 feet of fencing wants to build a rectangular garden. What should the dimensions be in order to maximize the area? Okay, so we have 100 feet of fencing, which means our perimeter is 100. So off to the side here, I'm going to sketch this garden, okay? So let's say that our width is x, and I'd really like to define the length in terms of x, okay? So if we were to call this y for right now, I know that 2x plus 2y is supposed to be 100 feet of fencing, okay? Divide everything by, well, let's just solve for y. Let's solve for y. Okay, so we're going to get 2y equals 100 minus 2x. Divide by 2, and we get 50 minus x. So we can let this length be 50 minus x. Okay, so that's the first thing we need to do, because we need to be able to put an expression for area into our y equals and then graph it and then take a look at where we could maximize it. Okay, so we need to define both the length and the width in terms of x, and I can do that because I know the perimeter was 100. Okay, so knowing that, our area is length times width for a rectangle, so that's going to be x times 50 minus x. So taking that into account, let's graph the area. Okay, so we're going to go into y equals, and we're going to put x and then times 50 minus x. Now, we're going to have to be a little bit careful about our window. Otherwise we're not going to see what we want. So let's think about this for a second. X represents the width here, okay, or the length. Well, the maximum we can go is 50, because if I go 50 minus anything bigger than 50, I'm going to get a negative number. So I'm going to let my x go 0 to 50, okay? And then y in this case, it's not the same as this y. Y represents our vertical height on our graph. That's going to be area, okay? So when I go x times 50 minus x, so let's just pick a number. Let's say I put in 20. I'd get 20 times 30, which is 600. So I'm going to maybe go to 1,000 just to make sure I've got enough, okay? So I'm going to go into my window. We said our x minimum would be 0 and our x maximum would be 50. And then I'd like to go 20 wide on the screen. So right now it's 50 wide, so I'm going to go 50 divided by 20. Okay, going on to the next one. 0 for an area all the way out to 1,000. And so then we'll go 1,000 divided by 20. Okay, and so that's how I'd like the window to be set up. That being said, I'm going to graph it. Okay, and we're going to get a parabola. And we're looking to maximize the area. So I'm really interested in the peak or the vertex of that graph. So if I go to calculate, I'm going to choose maximum there because that's what we're dealing with. It asks for a left bound, so I'm going to move the cursor left of where I think the maximum is, and I'm going to press enter. And then it asks for a right bound, so I'm going to move the cursor to the right of where I think that maximum is, and then I'm going to press enter. And then a guess, honestly the guess just has to be between those two, so I'm going to press enter there. Okay, and it's saying x is, well, for the most part, for all intents and purposes here, 25. Okay, now the question is, what should the dimensions of the garden be? Well, the width here is x. Okay, so it's going to be 25, and let's check our units. Feet. 25 feet by, and if you put a 25 back in for y, it turns out that's also 25. Okay, you end up with the square in order to maximize your area. So that's how I would tackle this one. Chapter 17 is going to be a lot of stuff with the calculator. So good luck, you guys.